Hey everyone, finishing up with inverse functions. The last video we talked about one-to-one functions, meaning that I take a function, take the inverse of that function. There is a relationship between the two equations. But notice I said I took a function, I took the inverse of a function. At one-to-one, test will show whether the corresponding relationship is two functions. So if my function f is one-to-one, then the inverse of that function is also a function. The domain of a one-to-one function is the range of the inverse, and the range of a one-to-one function is the domain of the inverse. Now, what we looked at in that in dealing with one-to-ones was a way to find it mathematically, algebraically, using numbers, using our domains and range, our x values and y values, using the equations, converting one to the other, all right, and being able to determine, is the original function, the inverse of it, also a function? I can also use a test graphically, the horizontal line test. This is very similar to the vertical line test. And what it says is simply if a horizontal line intersects the graph of a function more than once, then the function is not one-to-one, meaning that the inverse equation is not a function. So if I take the original function and I do a horizontal line test on it, if it intersects that function in more than one place, then the inverse is not a function. That original function is not one-to-one, meaning that, again, the inverse is not a function. So remember the vertical line test? We would take a vertical line and we would take it along the graph of a function, and if it struck the graph in more than one place, then it was not a function. That was the vertical line test. And what we were doing is we were looking at the domain. We were looking at the x values, seeing that each individual x, so if, for instance, this was 1 and this was 2 and this was 3, each individual x only had one corresponding y value. We could scroll along and be able to look at it, then yes, it was good. I can go ahead and take that original function and do a horizontal line test on it and be able to determine, will my inverse function also be, or the inverse relationship, will it also be a function? Inverse functions, the domain and range interchange. So what I was doing a vertical line test was on the domain of the original function. So vertical line test on my original function. But remember, they switch. The domain becomes the range. So what I'm actually doing on the original function now is a horizontal line test. And if it intersects more than once, then that inverse relationship will not be a function. F of x and the inverse of f of x have symmetry about the y equals x axis is an important aspect of this, and we'll look at that with a graph. But let's look at an example of what we're talking about here. A very good example is a parabola. If I did the vertical line test on this parabola, say this was f of x, and say this is my inverse of that, my vertical line test for this, as I slid this line along, it would only hit this graph in one place at a time. So therefore this is a function. That is correct. But if I did a horizontal line test on this, if I slid a horizontal line, I'm hitting it in two places all the way till I get all the way down here at the minimum. Okay? That lets me know, because remember, my domain and range flip. What I'm actually checking on my original function would be the range. And they're intersecting at two places, because once I take the inverse of it and I did a vertical line test on this function, and as I slid it across, I would be intersecting it in two places. So before I ever take the inverse, if I have a graph and I know what that function is, I can do the horizontal line test of it and be able to know that the inverse relationship, whether it would result in a function or just an equation. with my values that are squared, that is very difficult, having that inverse relationship. We saw that whenever we did the one-to-one. But for instance, like in even powers, make it difficult to have that inverse relationship where both are functions. But for a good number of my odd powered functions, I can have that. And the reason that I talked to you about y equals x and symmetry about it is that your odd functions are symmetric about the origin, in which my x of y goes through the origin. Your even functions are, there's not symmetry about the origin, it's symmetry about the x-axis. So if I did, here's my original function, and I looked at my vertical line test, and I went through and I was like, okay, it only hits the graph in one spot for every x value. So that's good. This is a function. Well, let me see if the inverse function of this will be a function. Then I draw a horizontal line and I slide it along, and it's only intersecting in one spot as I go through. Therefore, I know before I even graph it, yes, this, the inverse, would also be a function. And I can check that by doing my vertical line test on this one. Then I slide my vertical line along, and it's only intersecting the graph at one spot at a time. And that is my horizontal line test. Alright guys, watch your publisher videos. Critically think and structure your homework. Always thinking back to what we covered. That's what's nice about math. It's always building on the last thing or even the previous chapter. And good luck on your homework.